Good morning, friends. Yesterday we have completed the factors affecting evaporation and also just briefed about the various methods for measurement of evaporation. The methods already, as I mentioned, number one is evaporation pans, number two is empirical methods, number three is analytical methods. These are the three methods. In today's lecture, let us focus on these three. So the entire evaporation we have divided into three lectures. First one focused on what is evaporation and what are the factors affecting rate of vaporization or rate of evaporation. Second lecture is completely devoted to factors affecting evaporation. And this lecture is devoted to mainly the measurement of evaporation. That's how we planned the whole topic evaporation, and with today's class we will complete the evaporation part actually. So let us go into the lecture, into the methods one after the other in today's class. ISI standard pan, which is nothing but a modified pan, class A pan. So this is based on the codal provisions IS 5973 and is known as just a modified class A pan. What is that modification? First one is a pan is a cylindrical thing, just a cylindrical thing having larger area, right? Lesser height. Area is large, whereas height is very less. Like that we are taking a vessel. I will show the figure. Thus like that a pan diameter is 1220 mm. Whereas class A pan, if you take it, its diameter is a little bit less than this and depth is 255 mm. And there the depth is a little bit less. Otherwise not much differences. Class A pan and ISI standard pan are similar ones. Only thing is, first thing is these diameter values and height values. When I talk about an evaporometer, first I must mention what is the diameter of it, size of it, and what is the height of it, that which you are taking. This is first thing. Then the ISI standard pan is made of copper sheet actually. So that means whatever the cylindrical thing which I am talking about and the base, it is made of copper sheet actually. It's a copper sheet. Thickness of that copper sheet is 0.9 mm copper sheet. Whereas class A pan, it is only just galvanized iron. It's an iron pan actually. Whereas here ISI pan is basically a copper sheet pan, right? And it is tinned inside and painted white outside. So inside color is a tin color actually, whereas outside is they painted with mainly white outside. So this where we will keep. Now I am taking it a pan, circular pan or a cylindrical pan with size of 1220 mm, height is 255 mm with a copper metal actually, and that copper thickness of that walls how much and the base how much you are taking, it is 0.9 mm actually. Such a one, inside is tinned and outside is white paint is being put. And now this pan, what we will do it, this pan we will take it and keep on a square wooden platform. We have made a wooden platform of width 1225, because a little bit more than this, because we have to keep it a square wooden platform I have taken, so which is of 1225 mm, but its height is 100 mm on the ground. So what I will do on the ground actually, I will make it the ground also flat, and on the ground which is very close to the pond from where I want to measure, which is close to the river where I want to measure the evaporation, which is close to a reservoir where I want to measure the evaporation. Wherever I want to measure the evaporation from a water body, near that water body, we keep a wooden platform of size 1225 mm size and height is 100 mm. We keep it on the ground surface by making it leveled. Then after that, over that we keep this copper vessel which is having a diameter of 1220 mm, height is 255 mm and thickness is 9 mm. We keep it on that actually, and we allow, basically the area should be such that to allow free air circulation below the pan also, because the wooden platform should be such that there is a free flow of air under that also. That is one of the important. Then next one, what I will do, I will put a fixed point gauge in that particular vessel. What for actually? I already told the principle. Water to some level we fill the water so that we can measure the level. What I will do actually, next day again to fill that, the water level decreases because of evaporation. How much decrease has occurred I will see, and basically again I pour water to that level. So that decrease in that height, that is what we will say mm per day, this much evaporation has occurred. Then water is added, next principle, water is added to or removed from the pan to maintain the water level at a fixed mark. So inside I will make a fixed mark. Up to that we will add water actually, right? Then I measure the gauge. Next day morning I will come. So naturally this water level reduces. So that reduction in that level, how much we will say, and again I convert that depth into volume units using a calibrated cylindrical measure. The top of that pan, because problem is I cannot keep a pan open like this. The top of the pan is covered with the hexagonal wire net. It's a GI wire net actually. I will put at the top of the pan. What for I will put that? Suppose for example the birds may drink water from it, or for example you can say anything, any nearby any of the small animals or birds can really take water, try to draw water from it. So that's why it is not accessible like that. So that's why a mesh, wire mesh, which is a GI wire mesh, we put it on the entire pan actually. Presence of wire mesh makes the temperature of water more uniform. If you keep that wire mesh, the temperature will be more uniform during day and night. Evaporation from this pan, suppose now we calculated the evaporation. So for example, the evaporation from such thing, is it right completely? Can I take it as it is as evaporation? Whatever the evaporation that takes place from this metal container, can we take it as completely it is the evaporation? Definitely not. We need to apply some coefficient to get the original evaporation. So that's why whatever the evaporation pan gives, that will be 14% less compared to the original evaporation. Naturally, the evaporation pans always give lower, basically, that is about 14% lower compared to that from an unscreened pan actually. So this we will take it up. So evaporation, for example, if you take it, whatever you get, basically the evaporation multiplied by the pan what you call it, each has pan coefficient, that we will multiply. Naturally, because this metal is a smaller thing, evaporation will be more, so we need to multiply it by 0.7. So 0.7 or 0.8 depending upon the type of the pan, so to get the complete evaporation. So if you take IS standard pan, how the dimensions, just now we mentioned 1220 mm diameter, 255 mm height, and if you see 100 mm wooden platform, 1225 square wooden frame actually, copper sheet of thickness 0.9 and a wire mesh is put at the top. Then here actually it is the point gauge to measure the things, and this is a thermometer to measure the temperature. This is how it looks like. Actually, this one is a class A pan. How can I say this is a class A pan? The reason being, this is the metal, if you see, it is a galvanized basically iron. So GI metal sheet, that's why I am calling it as. If this is replaced by copper sheet, then we call it as same as what we call our IS standard pan. Now you see it is a wooden platform actually, and on that actually if you see freely air can flow below it also, if you see how the air flow can flow into it. So this total height is 100 mm we mentioned actually, and this is 1225 mm which we mentioned, and this diameter, if you say take it, we mentioned it as 1220 mm, and this height whatever it is which we have taken to 55 mm. So inside is, what is this? To measure the height of water actually. This is where in this only the point gauge is kept, right? This is the thing. So there are, in addition to this, there are some more instruments to measure the humidity, to measure the temperature, to measure the wind velocities. These are the instruments which are kept apart from the rain gauges that are being kept here. So this is what we have seen. So if you see how they have been kept also, this is another pan, this is another thing. So all these are all the same pans. So now if I go to the Colorado sunken pan, how it will be? It is a square pan. The difference between the previous one and this one is, it is a square pan. Previous one is a cylindrical pan. This is a square pan actually, 920 mm square pan made of unpainted GI sheet, and depth is 460 mm and buried into the ground within 100 mm of top actually. So the top is only this much we have kept, or 50 to 100 you can keep it, and rest should be buried into the ground. Total is 460. Out of the 460 you can keep 360 buried, 100 outside, or 380 rest outside, like that you can put. And it is a square thing rather than not, it is a base is not circular, it is not cylinder actually the pan, but it is a square thing. That is the first thing. The main advantage of this pan is its aerodynamic and radiation characteristics are similar to the lake. The Colorado sunken pan, basically the observation is once it is calibrated, the observation is it is more similar to the whatever is happening in a lake actually. And disadvantage is if suppose when the moment we have buried into the ground, we don't know how to detect the leaks, and very expensive to install also. Extra care is needed to keep the surrounding area free from tall grass and dust, because it is buried into the ground. The entire surrounding area you need to protect actually. So this is how it looks like with the Colorado sunken pan. Almost see the surrounding grass, almost it has grown to that height. Again wire mesh is same, but it is square actually, one fixed point gauge because to measure the height of thing, then it is buried fully into the ground. So this is the Colorado sunken pan, and this is at a higher elevation we have kept it. Different pans actually which you can observe. This is cylindrical pans or class A pan or ISI standard pan. This is sunken. Sunken means actually it is buried into the ground, a little bit, keeping a little bit above the ground level. Then what is pan coefficient? Pan coefficient is, pan evaporation is what we are going to measure. Lake evaporation is something naturally that occurs, and we are trying to equate this pan evaporation to the lake evaporation. If you want to do it, you need a coefficient. That is what we call it as pan coefficient. Lake evaporation, there is no way that we can measure straight away. So naturally we have to depend on pan evaporation. So because pan, that is possible to measure physically by using the fixed gauge. What is the principle of the evaporatometer actually? Evapometer. What is the principle, you tell me? The principle is we pour water to a fixed level, measure the depth of water actually. Now next day morning we come and again we measure the depth of water. Whatever that level has decreased, that we measure. This much mm per day decrease has occurred. That much mm per day is the evaporation. From where that evaporation? From that pan actually. Or otherwise what we can do it, this depth can be converted into volume units. So much volume is decreased. How you find out? Bring actually in a measuring jar the quantity of water. Again you fill the pans. While filling the pan again to the original level, you bring the water level. To bring the water level to original level, how much water you have added, that is what the quantity of water got evaporated from the evaporation pan. Can I take the evaporation pan, whatever water evaporated from the evaporation pan as the full evaporation? Definitely no, because the conditions in the evaporation pan are different. The conditions in the lake or reservoir or river are completely different. But how to make a correlation? That correlation is made through pan coefficient. What is pan coefficient? What is the evaporation from a lake? What is the evaporation from a pond? What is the evaporation from a reservoir? What is the evaporation from a river divided by the evaporation which you measured from the pan. So this is what the pan coefficient. So evaporation pans are not the exact models of large reservoirs. We are not modeling these pans with respect to a particular reservoir. They are having their own dimensions and we are going to install them by the side of that place where we want to measure the evaporation. Then the major drawbacks, or what are the drawbacks? They differ from reservoirs in the heat storage capacity and heat transfer characteristics. The heat storage capacity and heat transfer characteristics of the original reservoir are completely different from the pan actually. So because that is the first thing you should remember. From the sides and bottom, sunken and floating pans, to some extent they minimize this pan because they are sunken into the ground. Floating pan will be floating on the reservoir itself. So they reduce to something, but always you cannot go for them. So that's why the first thing is the heat storage capacity and heat transfer characteristics of the reservoir, original reservoir and pan are different. So hence how to transfer the results from one to the other. Next, evaporation from a pan depends to some extent on its size. Generally, what is the size we assume is 3 meters diameter. If you take it, it is almost same as from a large lake. Whereas from a pan of about 1 meter diameter, it is 20% excess. If suppose the diameter of the pan is reducing, is less, then naturally whatever evaporation that you are measuring is more than the lake evaporation. So that is why 3 meters, how much diameter we are taking right now? It is 1.22 mm only we are taking. So that means whatever we are measuring, basically from that it is 20% excess you are measuring. That will not be there in the lake. Generally, the reservoir evaporation is not to that extent. So that's why the evaporation measured by a pan is 20% excess if its diameter is approximately 1 meter. But if you take a 3 meter diameter, then it may be a little bit similar. But 3 meter diameter pan installing, and there it is not physically, it is something difficult actually. Then the height of the rim in the evaporation pan affects the wind action. The more the height of what you call it as the rim, naturally the wind is, the inside water is not exposed to the wind velocity. The lesser it is, naturally it takes. So that's why because of it, it also casts a shadow on the water surface. So that's why the evaporation is not representing correct evaporation. Already I mentioned the heat transfer characteristics of pan material are different from the reservoirs. Just now we mentioned already. Evaporation measured from a pan has to be corrected to get the evaporation. And how you get, so that's why the lake evaporation is equal to, or the reservoir evaporation is equal to, or the river water evaporation is equal to pan coefficient into pan evaporation. And this pan coefficient is always less than 1. Suppose if I take class A land pan, that which we studied actually first thing. So there actually the pan coefficient is 0.7. That means your pan evaporation is 30% excess. So if you want to bring it to the lake evaporation, 0.7 is the coefficient. Whereas ISI pan, if I take it, it is 0.8. That means whatever you are measuring by the pan is 20% excess compared to the original evaporation. Whereas Colorado sunken pan, it is 0.78 and USGS floating pan is 0.8. So these are the pan coefficients. Now you can see This is IS, this is a class A pan. This is Colorado sunken plan. So that's why I mentioned it is, you see rectangular thing wherein basically 90 centimeters, 92 centimeter by 92, approximately 920 square mm we mentioned, and its height also you can see here, and this is also same. Now you see this is perfect copper. This is ISI standard pan, and this is the basic thing is class pan. Class A pan dimensions, if you see, 1210 mm, whereas this dimension is 1220 mm. ISI. So this you should remember. So this is the floating pan. So it is floating on the reservoir water actually. So in between actually they have put this what pan actually. So it is floating on the reservoir itself and taking the things. So finally we have completed the various methods of measurement of evaporation. So naturally when you are experimentally doing it by evaporation pans, we call it as measurement. If you are estimating it by using some empirical methods, it's an estimation. Or if you are calculating it by an analytical method, it's a calculation. So whether you call it as measurement, you call it as estimation, you call it as calculation, all that leads to finally how to determine evaporation. That's the final question. So with this lecture, we have completed the complete topic of evaporation. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.